The U.S. military dropped 5,000-pound penetrator weapons into underground storage facilities, storing coastal defense cruise missiles and other support equipment. These weapons are bespokely designed to get through concrete and/or rocks and function after penetrating those barriers.
Iran built its coastal missile network underground for a reason. Buried beneath concrete and rock, hidden from satellites and strike aircraft, the facilities were designed to survive. Hardened chambers, reinforced tunnels, walls thick enough to absorb anything a conventional bomb could deliver. Admiral Brad Cooper, commander of U.S. Central Command, confirmed this week that those facilities no longer exist. Multiple GBU-28 bunker buster bombs were dropped on Iran's underground anti-ship missile storage along its coast. The results were total. The GBU-28 is not a standard bomb. It is a purpose-built underground penetrator, 5,000 pounds, nearly 19 feet long, a hardened steel casing machined from surplus 203mm artillery barrels filled with 630 pounds of tritonal explosive compound. The weapon was designed specifically for one task: to go through what other bombs cannot. It enters a hardened surface at high velocity, drives through concrete and soil, and detonates deep inside the structure after penetrating as far as 100 feet underground. Iran's coastal missile bunkers were built to withstand airstrikes. They were not built to withstand this. The aircraft that carried them to the target flew from outside Iranian radar coverage. The crews never crossed into defended airspace. The bombs did the rest. The mission began days before the bombs dropped. Intelligence analysts at U.S. Central Command had been tracking the facility for weeks. Overhead reconnaissance, signals intelligence, and subsurface mapping identified the exact layout of the underground complex. Yet the structure sat beneath a hardened ridgeline along Iran's coastline, reinforced with multiple layers of concrete casing. Inside were anti-ship cruise missiles on mobile launchers, reload munitions, fueling equipment, and command infrastructure. The entire facility was designed to survive a conventional strike and resume operations within hours. Conventional strikes would not be used. The mission was assigned to F-15E Strike Eagles from a forward-deployed squadron. The F-15E is the primary delivery platform for the GBU-28 in the U.S. Air Force inventory. It is one of the few aircraft in the world with the structural hardpoints and avionics integration to carry and accurately release a weapon of this size and weight. On the night of the strike, the aircraft taxied to the runway fully loaded. Each F-15E carried a single GBU-28 on the centerline hardpoint. The weapon occupied nearly the full length of the aircraft's underside. It was connected to the aircraft's AN/AAQ-33 sniper targeting pod, a laser designation system that would guide the bomb from release to impact. The crews ran through their weapon systems checks on the ground. Laser designator armed. Guidance fins confirmed responsive. Arming wires in. Release mechanism tested. Every system verified before the aircraft moved. The F-15ES took off in a two-ship formation and climbed to altitude. They flew a route that kept them outside the engagement range of Iran's remaining coastal air defense assets. Those air defense systems had already been significantly degraded in the preceding days by strikes from F/A-18 Super Hornets and Tomahawk cruise missiles. What remained was not capable of reliably tracking fast-moving aircraft at high altitude. The formation crossed into weapons release range at altitude above 40,000 feet. At that distance and altitude, the GBU-28 has sufficient terminal velocity to penetrate its target even before the explosive charge detonates. The physics are simple. A 5,000-pound steel cylinder traveling at several hundred feet per second carries enough kinetic energy to drive through meters of reinforced concrete before the fuse triggers. The lead aircraft designated the target. The sniper pod acquired the facility's surface access point, the hardened entry shaft into the underground complex. The laser spot locked on. The weapon system confirmed acquisition. The pilot released. The GBU-28 separated from the hardpoint and fell. Its guidance fins adjusted in real time, tracking the laser spot as it descended. The bomb traveled in near silence for the first several seconds. Then it hit. The impact was not an explosion. Not at first. The steel casing drove through the surface and into the earth, through the outer concrete shell, through the first layer of reinforced structural wall, through soil and aggregate and internal support structures. The penetration lasted less than a second. The fuse fired on the delay setting, detonating the tritonal charge at maximum depth inside the facility. The explosion inside an enclosed underground space is fundamentally different from a surface detonation. There is no place for the energy to go. The overpressure travels through every tunnel, every chamber, every connecting passage simultaneously. Unistructural walls that could absorb the force of an external blast are destroyed from within. The chambers collapse inward. The second aircraft released its weapon on the secondary access point of the same facility 7 seconds later. Both bombs detonated inside the complex within 1 minute of each other. U.S. intelligence assets monitoring the target confirmed the results within the hour. The surface entry points had collapsed. Subsurface imaging showed no structural integrity remaining in the primary storage chambers. The mobile missile launchers inside were assessed as destroyed. The anti-ship cruise missiles they carried were assessed as destroyed. The fueling infrastructure was assessed as destroyed. The facility that Iran built to survive airstrikes did not survive this one. Similar strikes were executed on 2 additional underground storage sites along Iran's southern coast the same night. Each facility had been identified through the same intelligence process. Each was struck with the same weapon. Each was assessed as destroyed. By the time the sun rose over the Strait of Hormuz the following morning, Iran's ability to threaten commercial shipping with shore-based anti-ship missiles from those locations had been eliminated. The launchers were gone. The missiles were gone. The bunkers were rubble. Iran had not been passive in the hours before the strikes. IRGC naval forces had deployed a small group of fast attack craft into the strait earlier that day. The vessels moved at high speed along the northern coastline, closing toward the shipping lane. Each boat carried rocket-propelled munitions and crew-served weapons. Their pattern of movement suggested a coordinated harassment run against commercial tankers transiting the waterway. The contact appeared on the radar of a U.S. Navy destroyer operating in the formation. The Combat Information Center tracked the fast boats as they accelerated. The threat classification was confirmed. The order went out. 2 AH-64 Apache helicopters already airborne on patrol over the strait received the coordinates. They turned toward the formation of fast attack craft and descended to engagement altitude. The lead Apache acquired the first vessel on the TADS targeting system. The 30mm chain gun opened fire at close range. The rounds hit the hull and the boat stopped moving. The second Apache engaged the trailing vessels in sequence. These 3 fast attack craft were destroyed. The remaining boats reversed course and withdrew toward the Iranian coastline at full speed. The engagement lasted less than 4 minutes from first contact to withdrawal. The corridor remained open. The bunker campaign did not stop with those 3 facilities. CENTCOM had a full target list. Intelligence teams continued to identify and map additional underground storage sites along Iran's coast. Munitions were already staged for follow-on strikes. Aircraft were already assigned. Mission planning was already underway. Iran built its underground network over decades. It believed depth and concrete were enough. They were not. Each facility that falls removes another layer of Iran's ability to contest the strait. Each launcher destroyed is one fewer threat to the tankers that carry 1/5 of the world's oil supply through that waterway. The F-15Es returned to base. Ground crews began preparing them for the next mission. The work never stops.